Alright guys, so yesterday we left off by going over this example of applying the law of detachment to draw real world and mathematical conclusions. So this example should already be written in your notes. So to start off this remainder of the lesson, you're going to go into your workbook and you should be open to page 24, I believe, and we're going to attempt to do number 2A. So when looking at this type of a question, we have gone over yesterday that law of detachment is when you're looking at the conditional is true and the hypothesis is true, and it will come to the statement of the conclusion being true. So with that being said, we're going to try and do this example together. So looking at this example, it says if two angles are congruent, then the measures of two angles are equal to each other. Angle 1 is congruent to angle 2. What can you logically conclude about the measures of angle 1 and 2? So first off, we need to pick out the key information. Identify P and Q. So you don't need to write this down. This is already in your workbook, but I'm going to write down. So P is two angles are congruent. And then the conclusion would be the measures of the two angles are equal to each other. Now, if we think about that statement, we know two angles can definitely be congruent. So say if we are looking at a 90-degree angle and we break it down into two angles, those angles are going to be 45 degrees, both of them. That is congruent. So that statement makes sense and can say that that statement is true based off that scenario. So if you want to be a visual learner and draw a 90-degree angle and we're saying we're breaking them in half, we can see that these are both going to be 45 degrees, making that statement true. And in the conditional overall, if two angles are congruent, then the measures of two angles are equal to each other. That is true. We can then say by the law of detachment that our conclusion is also true. And that is actually the answer that it is looking for. So we can say we can conclude that measure of angle 1 is equal to measurement of angle 2. And that's all you have to do for that example. Now, I would like you to pause this video and I would like you to try B. Same method, identify P and Q and think logically, can this be true? Or can I make this scenario follow these guidelines? So, if you have resumed this video, you have identified that P, the hypothesis, is you finish the race in under 30 minutes. And Q is you win a prize. And in this scenario, they tell you that you finish this race in 26 minutes. So, with this being said, that means that your statement Your hypothesis is true because you met the goal. You were under 30 minutes. Therefore, you can then say that statement is the conditional is true because you were under 26 minutes and you won that prize. So you can conclude that your answer would be, we can conclude that you win a prize. Now, if this scenario said that you finished the race in 32 minutes, what do you think is going to happen? Think about that for a second. If you won the race, if you finished that race in 32 minutes, are you going to win that prize? And the answer would be no. But if you think about that, that's actually the converse of the statement. If you do not finish in under 30 minutes, then you will not win the prize, which is still a true statement. But in this case, you did go under the 30 minutes, which was the hypothesis. Therefore, you met the conclusion and was statement of a true situation. So pause the video if you need to still write this down. If not, we're going to move on to the next example. So the next concept is law of syllogism. You actually already have that vocabulary written down. If you do not, it is still posted in Schoology in lesson 1.6. But in your notes, I would also like you to write down the thing that I highlighted in green. So law of syllogism, if P then Q and if Q then R are true, then if P then R is true. So now we're actually adding a third concept into the mix. So make sure you have that written down. Okay, so let's jump into example 3. So this is not in your notes, and I would like you to write down example 3. Assume that each set of the conditionals is true. What can you conclude about using the law of syllogism? And you are writing down A. So everything that is highlighted, I would like you to write in your notes. You may pause the video now, just so that you stay on time with what I am doing. Okay, so first off, I would like you to identify the hypothesis, so also known as P. So P is Kenji plays the trumpet. Q is Kenji plays a brass instrument. So, our statement for if P then Q, the conditional, would be if Kenji plays the trumpet, then he plays a brass instrument. Now, we're going to identify R. So, in the second part, he says if he plays a brass instrument, then he's a member of the marching band. So we're going to say Q is still he plays a brass instrument, but our new concept R is he is a member, or Kenji is a member of the marching band. In that new statement, if Q then R, would then be if Kenji plays a brass instrument, then he is a member of the marching band. And so this, just like the definition, the conclusion of one statement is the hypothesis of the other. So that is the difference between a regular conditional and now bringing in the law of syllogism. So based off this statement, we can conclude the following conditional is true. If Kenji plays the trumpet, then he is a member of the marching band. So I'm going to add a separate sheet of paper. We can conclude based off this that the following conditional is true if Kenji plays the trumpet, then he is in the marching band. Okay, now we're going to look at the next part of the example. So it says if points A, B, and C are collinear and B is between A and C, then the ray BA and the ray BC are opposite rays. If ray BA and ray BC are opposite rays, then AB plus BC equals AC. What can you conclude about that statement? So, you can draw this out. Since they said that we're looking at a ray, we can go with it going out here. So this would be A, B, and C. So let's pull out the key information. So P is points A, B, and C are collinear, and B is between A and C. Q is BC and the ray BC and or BA and BC. I apologize. Are opposite rays. And then our R would then be then AB plus BC is equal to AC. So based off the law of syllogism, we can then say that the conditional is true if points A, B, and C are collinear, and B is between A and C, then AB plus BC is equal to AC. And we'll explain more into this when I get back, but it's more or less just using the different laws that we are learning from the past 2 days and putting them into use. Alright, so I would like you to pause the video and I would like you to try example 3 in your workbook. The try it section, you're going to do A and B. So identify P, Q, and now R for both of them and see if you can make the conditional. So if you have resumed this video, you have identified P, Q, and R. So P, if an integer is divisible by 6, it is divisible by 2. If an integer is divisible by 2, then it is an even number. So the hypothesis is an integer is divisible by 6. The conclusion, also known as your Q, is the integer is divisible by 2. And then our new thing, the R, would be the integer is an even number. So say if we picked out a number randomly. Let's go with 12. Is 12 divisible by 6? The answer, yes. It would then give you 2. So that one works. Is the integer divisible by 2? Yes, because then 12 divided by 2, that works. And is it also an even number? Yes. So therefore that example makes that number fit in this scenario. Now, what if we did the number 35? Well, that one's not even one. How about 18? Actually, all numbers, it seems, that are going to be equal to all of them. So it actually works out due to it being an even number. It is 6 and it is 2. So let's make the new statement, since we proved that all that statement is true for these scenarios. So our new statement would be, if P, then R. It would be, if an integer is divisible by 6, then it is an even number. I'm just going to put a hashtag for shorthand. Now let's look at the next one. If it is a holiday, then you do not have to go to school. If it is Labor Day, then it is a holiday. So RP would be, it is a holiday. RQ would be, you do not or don't have to go to school. And our R, it is Labor Day. I say this because it actually said if it is Labor Day is the new concept. So that is my R, because we already have it as a holiday. We know that. That's the hypothesis. So in this case, we're going to have a Q and R scenario instead of a P and R. So you would say, if it is Labor Day, then you don't have to go to school. And this was actually, I made an error. It's an R to Q then, because of the order. If it was a Q and R, you would then say, if you do not have to go to school, then today is Labor Day. So I just switched them, but this was good. It's fine. So we are going to stop our notes section here, and I would like you to open up in Schoology. You're going to have an additional practice worksheet, and I'll post which numbers that you need to do in this section, and then you'll submit it to Schoology to receive credit when I get back. All right? Great job today, guys, and keep up the good work.